So today we are going to be dissecting the concept of risk and uncertainty. Yes, I can want you to have the understanding of this topic, even though when you get to professional level under strategic financial management, you are still going to do risk and uncertainty. It's still the same thing. The only thing is that the kind of question you are going to see on the day of your exam at that level may be different from what you are going to have at this case level. So, but the concepts still remain the same. All right then. So what do you mean by risk and uncertainty? Before we delve into the concepts, you need to understand that as a business, even as an individual, we take some level of risk. All right. Say, for example, when you are leaving from your home to the office early in the morning, all right? Of course, because you have done it in the past. Yesterday, when I was going to I left my home to the office safe and sound. I was able to get back home safely also. So, because of my past experience yesterday, I can predict that, okay, I will be going to the office tomorrow. Nothing will happen. All right? So I'm using my past experience to predict what tomorrow will be. Because every business environment or every individual or every business undertakes some level of risk, right? This is because the business environment itself, all right, the business environment involves the element of both risk and uncertainty. Uncertainty in the sense that it's not sure that that thing you aim to achieve, that you're going to achieve at the end of the day. All right? It's bleak. You can't predict it. You can't predict what the outcome will be. That's uncertainty. All right? You know, when a company is preparing a budget, during the budget setting, all the figures relating to sales, overheads, all the operating expenses like salaries, like the rent that the company will pay, all right, the utility bills in form of lighting, water, cleaning, all those stuff, all those expenses. When the company is preparing budget, it's only an estimate. The company is only producing an estimate. It will be different from actual cost at the end of the day or actual cash flow. So when the actual is different from what you budgeted for, that's a risk. All right? Because a company can say that because last year, 2024, we made so much sales in the market, and then we're able to sell 100 billion naira as an entity. Everybody is happy. Therefore, in 2025, I can use as a company, we can use our past experience based on what we did, based on our performance in the market last year, 2024. We can project that, okay, when we are when we are doing the planning and budgeting, we can predict that, okay, based on these assumptions, all right, we should be able to do 10% over our last year performance. So we are using past experience to project the future, to predict what the future outcome will be. That's a risk. All right. So this is what we are saying. But the actual results may be different from what you anticipate to achieve because of some external factors. Because business environment does not, the business entity does not operate in isolation. There are so many factors, both internal and external, that will affect the company's operation, okay, or the company's performance. For example, you can have events such as market volatility. There may be some kind of a gyration, or the market condition may not be too favorable for the company to achieve what it intends to achieve. That's a risk. Some economic variables. For example, inflation can limit the ability of the company to achieve what it intends to achieve. Okay? Not only that, where there is a political issue or circumstance within the business environment, that can also limit the ability of the company, okay, to maximize opportunity in the marketplace. So all these things are what we call risk, because it's beyond the control of the company. Cannot dictate what the market will, how the market will react to its products. So all these things are what we call risk. Okay, therefore, it is important for a decision maker to incorporate the element of risk and uncertainty involved in the variability of the cash flow, because your cash flow will always be different from what the actual cash flow will always be different from what you anticipate to achieve. That's what we call variability in cash flow. So when you are making investing decision, so it is important to incorporate the element of risk and uncertainty in that cash flow estimate, so that when you are preparing your budget, you need to incorporate some element of risk, because you don't have control over how markets will react to your product. And that's why it is important for you to incorporate that risk and uncertainty in your cash flow estimate. So that's just the background or introduction to this. Now, what do you understand by risk? Risk is a situation whereby future outcome is unknown, but it can be predicted with a past experience and probability of occurrence. What do I mean? When you are using your past experience with the help of probability to predict the future outcome, that is a risk. Okay? Risk is also a situation or is an event whereby part of the investment or the entire investments may be eroded. You know, when you make investing decision, when you put your money in an investment, there is no guarantee that you are going to earn the return on that investment. Even though you may have, some of you are proving stubborn. I don't know who is making noise. Please, always mute yourself. You know the rule. Now, when you make an investing decision, it's not certain that you are going to earn the return that you anticipate. Let's say, for example, you have 1 million naira. You then say, okay, before you invest that 1 million naira, you've already estimated that, okay, I should be able to earn 20% return on my investment. When you now commit the money on that investment, market condition can prevent the project for paying you back that return on investment of 20% you anticipate. For example, inflation. When there is inflation, the purchasing power of money will fall. The value of that 1 million naira you anticipate that you have invested will fall, will reduce. So this is what we are saying. So it is also possible that due to one reason or the other, you may lose the entire investment. A company may lose the entire investment. That's a risk. So when you are using your past experience to project or to predict the future outcome, that is what is known as risk. Okay? But uncertainty is different from that. Uncertainty is a situation whereby future outcome is unknown and it cannot be predicted with past experience and probability of occurrence. Okay? So when you cannot predict how the future outcome will look like, and you cannot use past experience and probability to do that, then that is uncertainty. However, in finance, both risk and uncertainty are used interchangeably. We use them together. We don't separate the two. All right, we don't separate. We use both risk and uncertainty to evaluate projects as far as finance is concerned. Okay, so that is as per that. Next item. Let's talk about methods of hedging risk and uncertainty in capital budgeting. Of course, as you can see from the screen, We have about 14 of them. However, we are going to talk about, we are going to talk about expected value method, standard deviation, coefficient of variation. We talk about probabilistic simulation. We are going to talk about sensitivity analysis and then decision tree. Capital asset pricing model is a topic on its own. We will get there. However, that notwithstanding, from this material, you can read about shorter payback period. It's the same thing that you know, the same payback period that you know. Discounted cash flow method is the same thing. Accounting rate of return is the same thing. Okay? So risk premium, risk adjusted premium, of course, this one is a method whereby a risk premium is added to the company cost of capital in evaluating a project. Say, for example, if a company cost of capital is 10%, so when you are using risk adjusted method, so you are going to, that risk premium will be given to you. The risk premium that can be, at times, the risk premium may be 5%. Therefore, when you want to calculate NPV, for example, instead of to use cost of capital of 10%, you are going to use 15%. So it will be cost of capital plus the premium, okay, plus the premium. So I will then use this 15% to evaluate the project, to calculate my NPV. That's what risk-adjusted method is talking about, all right? So again, it's a very straightforward kind of, I can't really test this kind of a thing because it's too cheap. A certainty equivalent method, the same thing. The equivalent factor will always be given to you. Just multiply the cash flow with the equivalent factor and with the discount factor to get your present value. So when you are calculating your NPV, it's as simple as that. Multiply cash flows with equivalent factors, all right? With that equivalent factor, it will be given to you, all right? Then you multiply with the discount factor as well. So when you do this, of course, you are going to get your present value. So you now add up all the present value of cash inflow minus present value of cash outflow. It will give you your NPV. Again, this is a very straightforward kind of, so however, where you have major work, these items, the one that I've listed already. So that's the one we are going to be discussing. Okay, we talk about expected value method. Okay, standard deviation and coefficient of variation. We'll talk about simulation, sensitivity analysis, and then decision tree. However, we are going to add one more, which is decision-making under uncertainty. Okay, decision-making under uncertainty, where you are going to have maximums, maximi, okay, Laplace, and all of that. However, I will still need to check if you have that element in your past question. Okay, I doubt it, because I think you still have risk and uncertainty in performance management too. So it's still there. So you can't be having that maximums in FM too. So, but in any case, let's move on. Let's talk about expected value method. What do you mean by expected value method? The expected value method is also known as mathematical expectation. It's also known as mathematical expectation. All right. It is determined by finding the average of possible outcomes. Okay. The expected value is determined by finding the average of expected possible outcome. So whenever you want to calculate expected value, all you need to do is to multiply probability with the cash flow of occurrence. Okay? The probability of each state of nature, you multiply with the cash flow. That will give you expected value. Okay? So say, for example, you are given probability in this form. Let's say this is probability, this is cash flow, denoted as X. This is probability, denoted as P. Okay, let me rewrite this one. All right. So you are now given probability, say, for example, 0.5, 0.3, and then 0.2. The underlying cash flow for the first one, let's say it's 1,000. This one is 1.5. Okay. Then this one is 800. So these are the cash flows and probability given to you. So when you now want to calculate expected value, you are supposed to multiply probability with the cash flow. This is the formula you are seeing here. Summation, expected value denoted as X bar, is calculated as summation of probability of X. That is, you multiply probability with a cash flow. X is the cash flow, P is the probability, X bar is the expected value. So in this case, for me to now get the expected value, I need to multiply probability with the cash flow. So 50% of 1,000 will give us 500. 30% of 1,500 should be, is it not 500 or what? What do you have there? 0.3 multiplied by 1.5. That's 450, yes. Then 20% of 800. So this will give us 160. I will then add everything together. 950, 1,000, 110. So this represents the expected value. This is how to calculate the expected value. Okay. The expected value is computed by multiplying probability of occurrence with the possible outcomes. All right. So generally, probability is attached to state of nature. State of nature is the event in the economy. So in the economy, you can have something like good, bad, worse, high, medium, low. Most likely, optimistic, most likely pessimistic. All right. So we can have boom, recession, steady. So when you have that kind of a thing in a question, that means you have been given state of nature. All right. So state of nature is the event in the economy. So that's basically expected value. However, this expected value is mostly preferred by a risk neutral manager or investor. Okay. Expected value is mostly preferred by a risk neutral investor or decision maker, such that as a risk neutral, such individual does not seek or avoid risk, okay, and is willing and ready to accept any outcome irrespective, okay. A risk neutral is willing to accept any outcome irrespective. If the outcome is good, so be it. If otherwise, no qualms. That's a risk neutral individual or decision maker. All right. However, when you want to make a decision on the basis of expected value method, especially where you have mutually exclusive projects, you know, we said when we had capital budgeting, we said that mutually exclusive projects are competing projects in which the acceptance of one will preclude the acceptance of the other. So if that is the case, under expected value method, where you have mutually exclusive projects, any project that has a higher expected value is the most preferred. Let's say, for example, you have project A, you also have project B. These are mutually exclusive, and you have calculated expected value for each of them. Let's say this one gave us expected value of 350. This one gave us expected value of 480. So when you now want to make a decision, because they are mutually exclusive, project B should be selected because project B has a higher expected value. Okay, so that is as per expected value. Now, it is also possible, examiner may ask you to calculate expected net present value. The expected net present value is not different from the normal net present value. The only difference is just that instead of you to use the company's cash flow, okay, instead of you to use the company cash flow to calculate your NPV.
Oh, Jesus.
Adejo, mute. Adejo. So instead of using the company's cash flow, instead of using the project's cash flow to evaluate to calculate your NPV, you are going to use expected value. Okay, you are going to use expected value. Say, for example, you have calculated expected value using this formula. Okay, you have calculated expected value using this formula. You do for year one, you have calculated expected value in year one to be 1,000. Year two, you calculate expected value to be 800. Year three, you calculated expected value to be 1,100. So when you now want to calculate your NPV, instead of using the company's normal cash flow, you are supposed to use the expected value. So this expected value will replace the cash flow. So the result is what is known as expected NPV. So the expected NPV is not different from the normal NPV, only that expected value is used instead of the project cash flow. That's all. All right. So as you proceed, you are going to see you are going to see how we are going to treat it. Okay. So that is as per expected value. We are going to talk about standard deviation, coefficient of variation before we have illustration. Okay, so next, let's talk about standard deviation. Now, standard deviation represents a statistical measure of absolute dispersion and is a measure of spread about mean value. Standard deviation is used to measure the risk inherent in a project. Where there are mutually exclusive projects, the project with a lower standard deviation should be accepted. Okay, so what we are saying is that when you want to measure the risk inherent in a project, you use standard deviation. So when you now have mutually exclusive, okay, when you have mutually exclusive projects and you have calculated standard deviation for each of them, let's say standard deviation of project A is 2. Standard deviation of project B is 3. So any project that has a lower standard deviation is most preferred, is better. All right. So in this case, project A will be selected and project B will be rejected. So because we are talking about risk measurement, standard deviation is used to measure the risk inherent in a project. When you want to determine project risk, you use standard deviation. So that means since you want to minimize your risk, and that's why you have to select any project with a lower standard deviation. Okay. Now, that is as per that. How do you then calculate standard deviation? How do you determine standard deviation? Standard deviation is calculated as the variance, as the square root of variance. You know, when you want to determine variance, we said variance is calculated as summation of probability of x minus x bar squared. This is formula for calculating variance. So to now get the standard deviation, all you need to do is to just find the variance, square root of the variance. That will give you your standard deviation. That will give you your standard deviation. Okay, if that is the case. Now, there are two different ways examiner can text you on standard deviation. If you're asked to calculate standard deviation, just normal standard deviation, of course, you are expected to use this formula. It is also possible, examiner may want you to calculate standard deviation of expected NPV. you may be asked to calculate standard deviation of expected NPV. So how do you do this? Now, the standard deviation of expected NPV can be calculated using two different formulas, depending on whether you are given independent cash flow or mutually dependent cash flow. Now, where you are given independent cash flow, independent cash flow is the one in which the events in each year are different. You don't have it here, let me put it down. Independent cash flow, okay? Independent cash flow is the one in which the events in each year are different. Excuse me. I didn't know that. Um, just give me just 1 minute. Let me. Okay. Okay, let's move on. Sorry about that breaking transmission. So independent cash flow is the one in which the events in each year are different. Okay. So what I'm trying to say here is that, say for example, you are given project cash flows in year one. For example, let me rewrite that. In year one, you are given a cash flow. Cash flow for year one to be 1,500, then 200. You're also given cash flow in year two to be 500, 500, 800, 300. So when the cash flow of each year are different, that means they are independent cash flow. Okay? So independent cash flow is the one in which the event in each year. So different events will affect the cash flow. So once the cash flow are different, that means they are independent cash flow. They are standalone cash flow. So independent cash flow is the standalone cash flow in which the events in each year are different. Okay? So when you now have to calculate standard deviation of expected NPV, you need to watch out before you put down your formula. You need to check from the question, what kind of cash flow am I given? Is it independent cash flow or mutually dependent cash flow? So once you notice that cash flow of year one is different from cash flow of year two, that means they are independent cash flow. So if they are independent cash flow, then the standard deviation of NPV, the standard deviation of expected net present value, will be calculated as the variance of each year, okay, variance of each year divided by 1 plus r raised to power 2t, okay? Then you find the square root. You find the square root. So this is the formula for calculating standard deviation of expected NPV, where you have independent cash flow. The d squared t represent variance in each year. So here, this guy here is equal to variance in each year. Okay. The R is the company cost of capital. Then T is the time period. Time period, it could be year one, year two, year three, and all of that. So that is how to calculate standard deviation of expected NPV. Okay, now What about where you are given mutually exclusive projects? First thing first, what do you understand by mutually exclusive projects? Mutually exclusive cash flow. A mutually exclusive cash flow is the one, the event, what am I? Mutually dependent cash flow, rather. I'm used to mutually exclusive. So mutually dependent cash flow. A mutually dependent cash flow is the one in which the events in each year are the same. All right? They are joint cash flow. This, let me put it this way. Mutually dependent cash flow is the one whereby or in which the events in each year are the same. Okay, so once you notice that across all relevant years, you are given the same cash flow, that means they are mutually dependent. For example, examiner can tell you that the cash flow is 40,000 naira per annum. The cash flow is 40,000 naira per annum. So let's say, for example, you are given a useful life for simplicity of 3 years. So since you have been told that 40,000 naira per annum, it means that year one, 40,000 naira is your cash flow. Year two, 40,000. Year three, 40,000. So that means when you are given such a cash flow, it means they are mutually dependent. It's a mutually dependent cash flow. So that's what I said. Mutually dependent cash flow is the one in which the events in each year are the same. So once you notice in a question that you have the same cash flow across all relevant years, that means it's a mutually dependent. So when you have a mutually dependent cash flow and you are asked to calculate standard deviation of expected NPV, therefore, you then say standard deviation. Okay, you can simply say standard deviation of expected NPV is calculated as standard deviation. It's calculated as standard deviation. Okay, then multiply by annuity factor. Standard deviation multiplied by annuity factor. So that will give you the standard deviation of NPV. Of course, that means you need to go and calculate your annuity factor. Then you need to calculate your standard deviation using this regular formula. So you need to calculate standard deviation using this regular formula. Okay, once you are done with that, then you calculate your annuity factor. And you know that annuity factor is calculated as 1 minus 1 plus 1 plus r raised to power minus n, then divided by r. So you get your annuity factor, you multiply with the standard deviation you have computed initially. If I don't want to use this formula, if I don't want to follow this route, then I can also calculate standard deviation as my standard deviation divided by 1 plus r raised to power n. Only that this method or this formula will take a longer process to compute. If I want to follow that route, let me look for a space. If I want to follow that route, I will just come here to say, okay, I want to calculate standard deviation of expected NPV, where we have mutually dependent cash flow. Therefore, I need to calculate standard deviation of year one. Let's say, for example, the project has 3 years life. So I'll calculate standard deviation of year one divided by the discount factor of year one plus standard deviation. The same standard deviation that I've computed, though, the same standard deviation I've computed. I would then say standard deviation divided by 1 plus r raised to power 2 for year 2. I will do for the final year. All right. So standard deviation, since the project has 3 years life, so standard deviation divided by the discount factor of year 3. I will sum everything together. I will get my answer. So let me write this one. Okay, expected NPV. All right. So what you have here, this same formula is what I've expanded. This same formula is what I've expanded here. It's the same thing as what you have here. Okay. So that is how to calculate standard deviation of expected NPV. Of course, this formula is shorter and is better. Just calculate your standard deviation, multiply with annuity factor. It's still the same thing you are going to get, because when you look at this, when you look at the denominator here, you will notice that all what you have at the denominator is the discount factor. Discount factor of year 1 plus discount factor of year 2 plus discount factor of year 3. That will give you annuity. By the time you add the 3 of them together, it will give you annuity factor. So instead of doing it one by one, why don't you just calculate annuity factor at once? All right, and you get the same answer, because your standard deviation is constant. You have this standard deviation, this dt, you've calculated it as square root of summation of probability of x minus x bar squared. Okay, f bar squared. So you've already calculated that. So instead of you to be doing 1 plus r raised to power 1 plus r raised to power, why don't you just calculate annuity factor once and for all? So that one is faster. Okay, so that is as per standard deviation. So before we solve question, let's talk about coefficient of variation. Let's talk about coefficient of variation. Just like we have done under standard deviation, the coefficient of variation is also used to measure the risk associated with a project. Okay, the coefficient of variation is a statistical measure of relative dispersion. You know, standard deviation is an absolute measure, but coefficient of variation is a relative measure of dispersion and is a measure of spread about mean value. Okay, it's a measure of spread about mean value. However, in a situation where different projects with different sizes are being considered, standard deviation may not be suitable, because standard deviation in that circumstance, standard deviation will not produce optimal solution. Therefore, a more relative measure of dispersion, which is coefficient of variation, should be used in this case. So where you have mutually exclusive projects, or when you have different alternatives, any alternative with a lower coefficient of variation should be selected. So when you have different alternatives, say for example, you have project X, you also have project Y, and you have calculated coefficient of variation for each of them. Let's say project X, you calculate coefficient of variation to be 10. Then project Y, you calculate project coefficient of variation to be 8. So in this case, because project Y produce a shorter or a lower coefficient of variation, project Y will be selected over project X. Okay, project X will be rejected. So when you want to consider the risk inherent in a project using coefficient of variation, all right, so and then where you have mutually exclusive project, you select anyone with a lower risk, because coefficient of variation measures the risk associated with a project. Okay, so that is as per that. Finally, under this, how do you compute coefficient of variation? The coefficient of variation can be calculated using two different formulas, depending on whether you have calculated standard deviation, regular standard deviation before, or standard deviation of the expected NPV. In a question where you have calculated standard deviation using this formula, which is square root of summation of x, summation of p of x minus x bar squared. So where you have calculated standard deviation, using this formula, and you have calculated expected value using this formula, which is summation of P of X, and you are now asked to calculate coefficient of variation. So in this case, coefficient of variation will be equal to the standard deviation divided by expected value. All right. But if in the question, you have calculated standard deviation of NPV, you have also calculated expected NPV, then in that case, the coefficient of variation will then be equal to standard deviation of NPV divided by expected net present value. That's it. That's all you need to do. It's as straightforward as that. All right? It's as straightforward as that. Okay, then. So if that is the case, at this point, we can have illustration. Let's have illustration. Let's have illustration. Let me see. Before that, do you have any question for me? If you have any question, let me know. If not, let's go straight to solving a question quickly. At least today, we should be able to complete expected value, standard deviation, coefficient of variation, and sensitivity analysis. Okay? So let's see. Let's see. What's this one talking about? Calculate the expected value of each, calculate the net present value of each. Okay. So let's start with this one. Let's start with this illustration number 3. Yeah. Step by Step Limited is a subsidiary of a group in the telecommunication industry. At the board meeting, the marketing manager put forward an optimistic proposal asking the management to commit a sum of 4.5 million naira to advertising and publicity campaign in order to increase its market share. So initial outlay in this question is 4.5 million. As the management accountant, the marketing director has asked you to verify if the project is worthwhile based on the data below. All right, so you have been given cash flow and probability estimation required. Calculate the expected value of cash flow in each period. B, calculate the net present value of the result when the initial outlay is 4.5 million naira and the company's cost of capital 15%. C, based on your calculation, advise the management whether it should undertake the campaign. D, list 3 advantages of net present value. So in this question, the examiner is asking us to calculate expected NPV. Even without asking you this number A requirements, when you're asked to calculate NPV, you should know that merely looking at the table, I can see probability, I can see cash flow. Once you are given probability and cash flow, it means that you have to calculate expected value. So without wasting more time, let me stop sharing this and move to the working notes quickly. Okay. So in this case, the name of the company is Step by Step. This is solution to illustration 3. That's the page, let me check. Page 71. Page 71. So, like I said, anytime you are given probability with cash flow, and you're also given state of nature, in this case, state of nature is optimistic, most likely, and pessimistic. So whenever you are given cash flow and probability together, that means you are supposed to calculate expected value. Now, when you look at this question, you will see that cash flow of each year are different, okay? cash flow of each year are different, but probability is the same. All right. So that means they are independent cash flow. Okay, because cash flow of year one is different from cash flow of year two, year three, year four. So they are independent cash flow. Okay, but examiner did not ask us to calculate what's it called? Standard deviation. So I don't need to sweat myself over that. So I will then come here. First thing first, examiner is asking us to calculate expected value. So to get the expected value, you are supposed to multiply. You are supposed to multiply probability with the cash flow. Okay, you are supposed to multiply probability with the cash flow. So in that requirement number A, so I can say calculating, the name of the company is Step by Step Limited. So I will say calculating expected value, which is X bar. So to get the expected value is calculated as summation of probability of X. That is, just multiply probability with the cash flow. That's all you need to do. Then you add everything together. So you are going to do it year by year. So starting from year one, I will pick. I don't need the state of nature. If you like, you can include it. But again, I will just come here. Please, Unisa, mute yourself. So for year one, we have probability. We also have cash flow. Then we have expected value. Of course, we can manage here for year two. The same thing, probability, cash flow, then expected value. Probability is denoted as P, cash flow is X. Okay, so according to the question in year one, what's the probability? The probability given to us is 0.2, 0.55, and then 0.25. Here is 0.20, 0.55, 0.25. Please, at all time, your probability must be equal to 1. Because if your probability is not equal to 1, you cannot have optimal solution. So if in a situation whereby your probability is not equal to 1, let's say, for example, you are given 0.2 for the last one. When you add up 0.2 plus 0.55 plus 0.2, it's not equal to 1. So in this case, all you need to do is to make the last figure equal to 1. So you then say 0.25. Then you state your assumption that it is that probability supposed to be equal to 1. However, the one given in this question is 0.95. It is assumed that the last probability is 0.25 instead of 0.2. That's all. You have told the examiner the challenges and how you are able to resolve it so that you can move on. You can't use probability that is less than 1 to calculate your expected value. It has to be equal to 1. Because if your probability is not equal to 1, you can't have optimal solution. So the cash flow for year one in this question is 2,014,1280. 2,014, then 1280. Remember, to calculate expected value, you multiply probability with the cash flow. So for the first one, 0.2 multiplied by 2,000. That will give us 400. Expected value is 400. Then 0.55 multiplied by 1,400. That's 770. Then 0.25 multiplied by 1280. 0.25. Pardon?
320.
320. Okay. So here is 320. To now get the expected value in the first year, I will add up everything. All right. So that will give us 1,390. 1,490 rather. 1,490. So that's the expected value in year one. Okay. I will then move to year two. Cash flow probability still remain as 0.20, 0.55, and then 0.25. Here is one. Okay. Then the cash flow of year two is different. In year two, cash flow is 2416 1440. 2416 1440. Again, I will multiply. This should be 480. Then 0.55 multiplied by 1600. 0.55 multiplied by 16. We have 880. Here is 880. Then 0.25. Okay. 0.25 multiplied by 1440 equal 360. Add everything together to get the expected value for year two. Okay. So this should be 360 plus 880 plus
Everything is 1,720.
480. That's 1720.
Yes.
So that's the expected value for year two. I will then move to year three. Again, probability, cash flow, expected value. So probability still remain the same. But cash flow in year three is different. 1800, 1520, 1240. 1800, 1520. Is it 1520 or 1540? Let me confirm.
Yeah,
1520
1520, 1240.
and then 1240. Again, you multiply
The first one is 360.
360,
Yes. Second one is 836.
836,
Yes. The third one is 310.
310. Then we add everything together. That's
1506.
1506. Finally, I will do for year four, period four. The same probability, but different cash flow. Okay. Because you cannot you can't do everything on the same line, on the same row. It will be too voluminous. It will be too voluminous for 4 years. So you can't do everything together in the same on the same row. For example, you do for year one, cash flow of year one, expected value of year one. Okay, cash flow of year two, expected value of year two, cash flow of year three, expected value of year three. So by the time you put it will be too much. Okay, it will be too much. And that's why it's better for you to do separately the way I've done it. Okay, so probability still remain the same as 0.20. 0.55, and then 0.25. Abba, hold on. Andrew, I'm coming for you. Then cash flow of year 4.
2018, 1006.
Okay. 2000, 1800, then
Yeah.
1600. So here will be 400.
Second one,
Then
990.
990. Then 0.25 multiplied by 1600.
400.
400. Then you add everything together. That will give us 1790. So that's the expected value for year 4. Okay. Now that we have computed expected value, I can then proceed to calculate NPV. All right. So because in the question, the examiner asks you to calculate expected value, and that's what we have done so far. Then number B, you have to calculate the net present value of the results. When the
Tell him to enter then. I already told him I'm in a class. He said no
Moses,
problem. Huh?
have you forgotten you are in the class?
So,
So number B, you have to calculate NPV at the cost of capital of 15%. So I would then come B. Sorry, Andrew, go ahead with your question.
So, sir, I was trying to understand. So far, we have the same probability for the respected years, year 1 to 4.
Yep.
What about to write probability? Then we put year 1 cash flow and expected value, year 2 cash flow and expected value, year 3 cash flow down to year 4, without repeating the probabilities. At least that will minimize space. And
That's what
I don't know if that.
that's what I said. That's what I said it will be too voluminous on the, especially if you have to calculate variance, for example. So like I was said the other time when I wrote down cash flow here. Of course, you know that the first year probability is this. All right. Probability is constant for the three of them. Okay, 0.20, 0.55, then 0.25. Okay, this probability of 1 is constant for all of them. For year 1, for example, year 1, I would then say cash flow of year 1, the expected value of year 1. Then in year 2, cash flow of year 2, expected value of year 2. All right, then cash flow of year 3, expected value of year 3. Cash flow of year 4, expected value of year 4. Of course, this will be for year 2, year 3, and then year 4. All right, of course, you can do it. But what I'm saying is that it will be somehow, you can do it on the same row, but it will be too tight. It's kind of I mean too tight together. So it's better we do it separately. If you want to do it, of course, the examiner will never penalize you, provided that you know what you are doing. Like in this case now, all I need to do is to just structure my table. All right. In that case, I have to rule everything. I have to rule it. I'll rule it. I'll then divide this one into 2. This one will be separate. This one will be separate. This one will be separate. This is year 4. Okay. I will divide this one into 2. Into 2. Into 2. Of course, we get our answer, the same answer we have gotten before. This one will be the expected value. This one will be the expected value. This one will be the expected value. Expected value for year 4. Of course, you can do it that way. That's not a problem. It will make it faster for you, which is not, there's nothing bad in doing that. All right. But in the question where your examiners ask you to calculate standard deviation, in that case, that means you need to extend your table beyond what you have here. So you cannot, this one will not work. But as for this, you can do it. Andrew, hope you are fine now.
Yes, I'm fine, sir.
Okay,
Thank
then.
you.
So, number B, calculating NPV, net present value. Okay. So, now I told you that when calculating, whenever you are given cash flow and probability and you are asked to calculate NPV, what examiner is simply telling you is to calculate expected NPV. Okay, this is expected NPV. It's not just NPV, it is expected NPV. So to do this, the same way you normally calculate NPV, you create column for year. All right, if you like, you can include description of items. Then you have cash flow. We have discount factor, cost of capital of 15% according to the question. Is it 15% or 10? Let me check. Yes, 15%. Then we have the present value. So year zero, there are 4 periods, year 1, year 2, year 3, year 4. So we have the initial outlay here in year zero, which is 4.5 million. So put our number in thousand. 4.5 million naira is 4,500. Since our number is in thousands, okay, figures in thousands. All right. Then the expected value we have calculated. In this question, I'm not sure we have scrap value. Let me confirm. Yes, we don't have, we are not given any scrap value. All right. So if that is the case, I would then say we have calculated expected value in year 1 should be 1490. Here is cash outflow 1490. Expected value in year 2 1720. Year 3 expected value we calculated 1506. Then 1790 for year 4. So I will then calculate discount factor for year 1 at 15%, which is 0.870. Okay. 1.15 raised to power 2 minus
0.756.
0.756. Then year 3 is 0.712, right?
No, 0.658.
658.
Yes.
Then year 4.
Year 4 is 0.572.
Okay. So to now get the NPV, expected NPV, you multiply. Here is 4,500. So I can do the last one. 1790 multiplied by, 1790. 1790 multiplied by 0.572 equal 1024. Here is 1024. Right? 1506 multiplied by 0.658 equal 991. Then year 2, 1720 multiplied by 0.756 equal 1300. Then year 1 present value 1490 multiplied by 0.87
1296.3.
1296.
0.3.
So I will then I will add up the positive present value. I will minus that. So 1296 plus 1300 plus 991 plus 1024 equal 4661 minus 45. The NPV is 111. Okay? NPV is 111. 111. This is the expected NPV. So this is how to calculate expected NPV. All right. So whenever you are asked to calculate expected NPV, you need to first of all calculate expected value. You then use your expected value to go and compute NPV. The result is what is known as expected NPV. So it's as straightforward as that. Okay. So let's move on. Okay. Let's go to illustration number 5. Let me stop sharing this. Before I switch, any questions so far? Any question? If there is none, then let's move on. So stop sharing this. Let's move to illustration number 5, where we have standard deviation, NPV, standard deviation, variance, coefficient of variation. Okay. Equatorial Limited has an investment proposal that has the following probability distribution of returns. Okay. The events of each year are independent of other years. The outlay on the project is fixed at 22,000 naira and the appropriate discount rate figure is 10%. Required, calculate the expected net present value, the variance of return in each of the years, the standard deviation of net present value, and the coefficient of variation. So that's the requirement. So quickly, let's solve this question. We want to calculate expected NPV. Again, before you compute expected NPV, you must first of all calculate expected value for each year. You can see that cash flow in each year are different. The cash flow of year 1 is different from cash flow of year 2, is different from cash flow of year 3. That means they are independent cash flow. Because in number 3 requirement, examiner is asking you to calculate standard deviation of the net present value. So you need to ask yourself, what's the nature of the cash inflow? Are they mutually dependent or independent? So they are independent. In fact, examiner also told you in this paragraph that the events of each year are independent of other years. That means they are standalone cash flow. Okay. Yes. Okay. Okay. What's your question?
Good evening, sir. Sorry, it's
Good
just
evening.
the C part of the first question. They said the calculation advise the management. What kind of advice should we give based on this result of
Okay.
111?
Yeah, so since you are asked to advise and we have calculated our NPV is positive, then the project should be undertaken. All right. So thank you for even bringing that up. You know, we did not advise. So since we are asked to advise in the question, I would then say the project or the campaign. Okay, let me go back to the requirement first. The requirement is saying that based on your calculations, advise the management whether it should undertake the campaign. Then I would then say the management of step by step should undertake the campaign, the market campaign, the marketing campaigns, since the NPV is positive. Okay, since the NPV is positive, that's it. So, yeah, solution to illustration 5. I think that's still on page 47. Let me confirm. Page 72, rather. Page 72. The name of the company is Equatoria Limited. All right. So in this particular question, number one requirement says you should calculate expected NPV. There's no way you can just go ahead and calculate expected NPV. You need to first of all calculate expected value for each year. So first thing first, and then again, number two requirement, we are to calculate variance. So we are going to match together the expected value and variance. So more like a working, all right? So I will then say expected value and variance. Okay, so we're starting from year one. This will be for year one. So to do this, we indicate probability, cash flow, okay, expected value. This is P, this is X, cash flow. Then, because we want to calculate variance, remember, variance denoted as D square is calculated as summation of probability of X minus X bar square. Let me write that to make it clearer. Okay, so this is the formula for calculating variance. So I need to expand this formula. To do that, I will then create a column for X minus X bar. Okay, I will create another column for X minus X bar square. Then the last one will then be probability multiplied by X minus X bar square. Okay, so that will, the last column will be for my variance. So for year one cash flow and probability, according to the question, year one cash probability is 0.2, 0.4, then 0.4. So here is 0.2, 0.4, then 0.4. Okay. Of course, like I said, your probability must always be equal to 1. Then the cash flow of that year one, according to the question, 6,000, 8,000, 9,000. 6,000, 8,000, 9,000. Then you multiply. This will give us 1,200. 8,000 multiplied by 0.4. So that should be 3,200. Okay. Sorry, yes, 3,200. Then here will be 3,600. When you add it up, that will give us 8,000 naira. So that means expected value in year one is 8,000. So to now get the variance, we've already expanded the formula. Therefore, X minus 8,000. 6,000 minus 8,000 will give us minus 2,000. Minus 2,000 square will give us 4 million. 4 million multiplied by probability of 0.2 will give us 800. The second one, the second row, 8,000 minus 8,000 is 0. The third row, 9,000 minus 8,000 is 1,000. 1,000 squared is 1 million naira. 1 million multiplied by probability of 0.4 will give us 400. When you add it up, 1,200,000. So variance in the year one is 1,200,000. Of course, you can complete your table. All right, so I will then do for year two. Okay, what's your question?
So I'm actually lost from that variance area. How did we get the 2,000? I don't remember about. Let me see. From that variance area, I'm
Just
actually
pay
lost.
attention to the second one we are doing. All right. So it's the same thing we want to repeat in the second year. Just pay attention. So cash flow, expected value. You already know the formula to be probability multiplied by x minus x bar to get the variance. So I will expand x minus x bar, x minus x bar squared, then probability of x minus x bar squared. So the probability of year two is 0.5, okay, 0.5, 0.50, 0.50, here it will be 1. Okay, then cash flow of year two is 8,000, 12,000, 8,000, 12,000. When you multiply, there will be 4,000 expected value, okay, 6,000 expected value. Add everything together, we have expected value of 10,000 naira. Okay. Now, to get the variance for year two, 8,000 minus 10,000, the first cash flow, X is the cash flow, P is the probability. So you are doing X minus X bar. You are following the formula. The formula here is X minus X bar. 8,000 minus 10,000. So that will give you minus 2,000. Minus 2,000 squared is 4 million. Then 4 million multiplied by a probability of 0.5 will give you 2 million. Okay? So because whatever you are writing in each cell, it depends on the formula you have on the heading. Okay? So the cash flow of the second row is 12,000. 12,000 minus expected value of 10,000 will give you 2,000. 2,000 square is 4 million. Angela Laye.
I'm so sorry.
It's okay. Now, 4 million multiplied by 0.5 will give us 2 million. Add the two together, 4 million. So variance in year two is 4 million. I will then move to year three. Okay. Do you understand now how we got the variance?
Yes, I do. Thank you,
Or
sir.
you still have concern? Speak up.
Mm, mm.
Do you still have concern?
No, I've seen how we got it. We use the so I didn't realize that the cash flow was abbreviated as X. So I just realized that, and then cash
Oh,
flow
okay.
minus the expected value
Expected
that we
by
got.
value.
So
Yeah,
square.
it's okay. No worries. So probability, cash flow, expected value. Then for year 3, probability of year 3 is 0.3, 0.5, 0.2, 0.3, 0.5, 0.2. Here is 1. Then cash flow of year 3 is 7,000, 11,000, 17,000. 7,000, 11,000, 17,000. 30% of 7,000 is 2,100. 50% of 11,000 is 5,500. 20% of 17,000, 3,400. When you add it together, we have that's 11,000. Okay, that's 11,000. Okay, so if that is the case, we need to get the variance. So here will be x minus x bar, x minus x bar square. Then probability of x minus x bar square. Variance of year 3. So 7,000 minus 11,000 will give us minus 4,000. Minus 4,000 square will give us 16 million. 16 million multiplied by probability of 0.3. What do you have there? That should be 4, let me confirm, 16 million multiplied by 0.3. That's 4.8. 4.8. All right, 11,000 minus 11,000, 0. 17,000 minus 11,000 will give us 6,000. 6,000 squared, that's 36 million. 36 million multiplied by 20%, that will give us 7.2 million. When you add it together, variance of year 3 is 12 million. All right, so that's that. Then, according to the requirements, you have to calculate expected value. We have done that. We have not calculated expected NPV. So you have to calculate variance of return in each of the 3 years. So to now get the expected NPV, calculating expected net present value. Okay. So create a column for a year. If you like, you can put description of items. If you like, you can ignore it. Discount factor. According to the question, the cost of capital given to us is 10%. So at 10%, then present value. Year 0, 1, 2, 3. So initial outlay of the project is 22,000. Expected value we calculated in year 1 is 10,000, sorry, is 8,000. So here is 8,000. Year 2 expected value is 10,000. Year 3 is 11,000. So this is what I was explaining to you the other time, that whenever you are asked to calculate expected NPV, the first thing you need to do is to calculate expected value for each year. Then you now use your expected value to compute the NPV. The result is what is known as expected net present value. So discount factor at 10% for year 1 is 0.909826751. So you multiply, here will be 22,000. 8,000 multiplied by 0.909. 8,000 multiplied by 0.909 equal, that's 7272. Then here will be 8260. 11,000 multiplied by 0.751. That's 8261. Then we need to calculate the expected NPV. Okay. I would then say 8261 plus 8260 plus 7272 equal, then minus 22,000.
1793.
1793. The expected NPV is 1,793. Okay, that's it. It's as simple as that. Then, number 2 requirements. Examiner wants you to calculate, we are asked to calculate variance. We've already calculated variance in each year. Okay, variance in each year. So we've done that already. In year 1, we calculated variance of 1.2 million. Year 1, year 2, year 3, 1,200,000. Then in year 2, 4 million. In year 3, 12 million. That's it. Okay. Then number 3 requirements, according to the question, we are to calculate standard deviation of net present value. So before I put down my formula, I need to check from the question, what's the nature of the cash flow? Examiner has told you that the cash flows are independent of other years. Even without examiner telling us, we can see that the cash flow of year 1 is different from the cash flow of year 2 and then cash flow of year 3. So that means they are standalone cash flows. They are independent. Okay, calculating standard deviation of NPV. So, since the cash flows are independent of other years, therefore, standard deviation of expected net present value will then be calculated as variance in each year divided by 1 plus cost of capital raised to power 2t. Then you find the square root. Okay, you find the square root. So in this case, I would then say standard deviation of NPV equal variance of year 1 is 1,200,000 divided by cost of capital is 10%. 1 plus 10% will give us 1.10 raised to power 2 times year 1 plus variance of year 2, which is 4 million, divided by 1.10 raised to power 2 times year 2 plus variance of the third year, which is 12 million, divided by 1.10 raised to power 2 times year 3. Okay, then I will find the square root. So we're doing it step by step. In the first year, so here is 1.2 million divided by discount factor, 1.1 raised to power 2. Okay, 1.1 raised to power 2. That will give us 1.21. Here divided by 1.21 plus 4 million divided by 1.1 raised to power 4. That's 4641. Let me confirm. 1.1 raised to power 4. 4641. 1.4641. Then the third year, here is 12 million. Variance of 12 million divided by, let me write that. So variance of 12 million divided by 1.1 raised to power 6. Okay, 1.10 raised to power 6. That's 1.771. 1.771 561. 561. Then you find the square root. So there's no need for you to be doing step by step again. It's a waste of time. You can just use your calculator to get the final answer. So standard deviation of expected NPV. So you carry your calculator, follow me. So you open a bracket from your calculator, open a bracket. Let me remove what I have from my. So you open a bracket, then you say 1.2 million divided by 1.21. Close the bracket, plus, open another bracket, 4 million divided by 1.4641. Close the bracket, plus, open another bracket for the third year, 12 million divided by 1.771561. Close the brackets, then press equal to. All right, you are going to have 10,497,476.519 or thereabouts. Then just press square root in your calculator. Just press square root. Okay. So that'll give you 3239.98. So that's 3240. This is approximately 3240. So this represents the standard deviation of NPV. So this is how to calculate standard deviation of NPV where you are given independent cash flow. Okay. Then number 4, you have to calculate coefficient of variation. So number 4, coefficient of variation. And I told you that coefficient of variation, the formula to use for calculating the coefficient of variation will depend on the standard deviation and then expected value that you have computed. In this question, we have calculated expected NPV. We have also calculated standard deviation of expected NPV. Therefore, coefficient of variation will be standard deviation of NPV over expected NPV, which is equal to 3240 3240 divided by 1793. This will give us 1.8. Is it 1.81 or 1.80? Let me confirm. 3240 divided by 1793. Yeah, 1.81. That's it. That's end of the question. Let me know if you have any question on this. Let me know. Okay. So that's that as per coefficient of variation. Let's have one more illustration whereby you are given mutually dependent cash flow. Let's solve questions that involve mutually dependent cash flow. Okay, let me go back to the question material. This is sensitivity. Okay. This is true. Okay, so let's solve this illustration number 6 then. Let's solve illustration number 6. Yes, I need one of you to read for us. Yes, Angela, read for us.
Okay, sir.
Yeah, thank you.
Johnson Limited is considering whether to invest in a project which would entail immediate capital expenditure on equipment worth 40,000 naira. The expected sales volume from the project are given below. The probability and then sales units. The unit selling price is 15 naira. Variable cost per unit is 9 naira. Once sales are established at a certain volume in the first year, they will continue at that same volume in the subsequent years. The useful life of the project is 6 years, and the equipment will be sold for 5,000 naira after the end of the project. The company's cost of capital is 10%. You're required to calculate the expected net present value of the project, the standard deviation of NPV, the coefficient of variation.
Yeah, thank you very much. Yes, that is the question. Examiner is asking you to calculate expected NPV of the project. You want to calculate expected NPV. So you need to first of all calculate expected value. After that, you then use your expected value to compute the NPV. The result is known as expected NPV. So without wasting more time, when you look at this question, cash flow is not given to you. Remember, to calculate expected value, you are supposed to multiply probability with the cash flow. But cash flow is not given. Instead of cash flow, examiner has given to you sales volume. Therefore, you need to go and do working for cash flow. How do you get your cash flow? You can see in this question, you are given selling price of 15 naira. You are given variable cost of 9 naira per unit. So that means you need to calculate contribution margin. So to get your contribution, selling price of 15 naira minus variable cost of 9 naira, that will give you 6 naira. So contribution per unit is 6 naira. Once you have the contribution per unit, you then multiply with the sales volume. So you add up, you multiply with the sales volume. So that will give you the cash flow. So once they have the cash flow, you can then come and calculate the expected value. When you get the expected value, then you go and calculate expected NPV. That's all you need to do. So because of time, let me stop sharing this and move to the working notes quickly. Okay, so solution. So illustration number 6. All right. We are still on page 72. Okay. So the name of this company, the name of the company is Johnston Limited. Johnston Limited. So like I said, in the A requirement, examiner wants us to calculate expected net present value. You can't just proceed to calculating the expected net present value. You need to go and do your working first, because for you to be able to calculate expected NPV, you need to first of all calculate expected value. To get expected value, you multiply cash flow with the probability. In this question, you are not given cash flow, so you need to go and do working for your cash flow. Once you get the cash flow, you multiply with the probability, it will give you the expected value. Okay, so this would be for expected value, NPV, then coefficient of variation. Let's go to the third page for our working. So I will then come here, working number 1. I want to calculate contribution. Okay, and I know that contribution is equal to selling price. Contribution, see, so contribution is selling price minus variable cost per unit. Okay, therefore contribution selling price in the question is 15 naira. Variable cost is 9 naira. Therefore contribution per unit is 6 naira. Okay, now that I've calculated contribution per unit, I need to calculate total contribution. So to get the total contribution, you multiply number of units with the contribution per unit. So in this case, we have the sales volume, you multiply with the contribution per unit, then that will give us total contribution. So your total contribution is the cash flow we are looking for that is not given. So for each the sales volume 2,000, 1,800, 1,500, 2,000, 1,800, 1,500, 2,500, and the last one there, the last unit is 1,000. Okay, there is 1,000. Then contribution per unit is 6 naira. We multiply. Here will be 12,000 naira. Here will be 9,600. 8 times 4, 9,400. 1,800 multiplied by 6. 1,800 multiplied by 6, just to be sure. 10,800. Okay, here is 10,800. Yeah. Then here will be 9,000. Here will be 15,000. Then here will be 6,000. Okay. All right then. So now that we have the cash flows that we are looking for, I will then go ahead and calculate my expected value. So I will then come here. First thing first, for me to be able to calculate expected NPV, the first step I will do is to calculate expected value. So I will then say expected value in the question, you are also asked to calculate standard deviation. So that means I need to calculate variance. All right, so I will calculate expected value and variance. Okay. So to calculate the expected value, you need to multiply probability with the cash flow. And because we want to calculate variance as well, so we need to extend this. So probability is P, cash flow is X. So X minus X bar, X minus X bar square. Then probability of X minus X bar square. So give me the probability as given in the question.
0.15,
Uh-huh.
0.20,
Uh-huh.
0.35,
Okay.
0.10,
So the first one
0,
is 0.15. 1.15. Okay. 10,
2035. Yes, 10, 0.20.
0.20. So when you add it up, you must have 1. Everything must be equal to 1. Okay. 3535, yes, is equal to 1. Then the cash flow that we have computed, the first cash flow we calculated was 12,000, 10,8. 12,000, 10,8. Here is 12,000, 12,000, 10,8,
9,000.
9,000, 15,000. And the last one is, I think the last one there is 6,000. Here is 6,000. So to now get the expected value, you multiply the cash flow with the probability. So 15% of 12,000.
That's 1.8.
Pardon?
12, 1.8.
12, okay, 1,800. All right. Here is 2160,
3150,
3150,
1500.
15, then 12. So we then add everything together. So what do you have as total?
9810.
9810. That represents the expected value. Expected value. Okay, so now get the variance. You need to minus first thing first, you minus the cash flow. You minus the cash flow from the expected value. So 12,000 minus 9810. 12,000 minus
2,190.
9810. 2,190.
190.
2,190 square. Okay, 2,190 square.
4796.
4796.
96.
100.
100.
4796 100. Okay. Then the second one, 10,800 minus 10,800 minus
Sorry, sir. And then the last one, 719415. That's the probability of it.
okay. The last one,
719415. Yes, for the first row.
7. Okay, probability. Sorry,
Yes,
719
415.
415. Thank you. So 10,800
minus 9,
minus 9810
990,
990 square.
980. 100.
100 multiplied by 0.2.
196.
19020.
Sorry.
196,020. Okay. Then the third one, 9,000 minus 9810. That will give us minus
Minus
810.
810.
Minus 810 square.
No, we put them
656
square.
65,
100.
100. Multiplied by 0.35.
229
0
63
to
229
229.
635.
Okay. So the fourth one, 15,000 minus 9810.
5190.
5190 square.
26
Okay.
936 100.
Multiply by 10%. Now 2,693,000 and 610.
10.
610. Then the last one, 6,000 minus 9810 minus
Plus
3810.
3810.
So minus 3810 square.
145
145
161
16100, right?
Yes,
So
yes.
multiply by 20%. 2 million
2,903,220.
90220. So let's add up everything.
Sorry, sir. The ones that came with negative, how do we treat them? Are we supposed to put them in brackets or leave them like this?
So when you make negative times negative, we give you a positive now. When you do 8 minus 810 squared, so you get positive. All right. So what's the total answer? The total value?
67 41,900.
11.
41,900.
Okay,
41,900.
41,900. Okay, so that's the total variance. That's the variance. So in the requirement, examiner wants you to calculate expected NPV. So I can then say, number one, expected net present value. So I will create a column for year, description of items, cash flow, discount factor at 10%, then present value. Okay, so to get the expected NPV, you are supposed to use your calculated expected value. All right. Initial outlay of this project, according to the question, is 40,000. Initial outlay is 40,000. Then the useful life of the project, we are told is 6 years. Okay. The useful life of the project is 6 years, and equipment will be sold for 5,000 naira after the end of the project. Okay. So in that case, this 9810 expected value we have calculated is cost flow. The expected value is 9810. Year 1, 9810. Year 2, 9810. Year up to year 6 is the same cash, is the same amount. 9810. Then at the final year, we have a scrap value of 5,000 naira. So I need to go and calculate annuity factor of year 1 to 6 at 10%. Okay. So annuity factor, working number 2. You have calculated it. What do you get? What did you get? So annuity factor equal to 1 minus 1 plus r raised to power minus n all divided by r, which is 1 minus cost of
0.1.
capital is 10%. So useful life is 6 years divided by 0.10. You say it's what?
4.355.
4.355. So that's the annuity factor of year 1 to 6 at 10%. Okay? All right. So I will then come here 4.355. Here is 4.355. Let me rewrite it, make it bolder. Then discount factor for year 6 at 10%. Discount factor of year 6 at 10%. So 1.1 raised to power 6 minus 0.564. 0.564. So let's multiply. So here will be expected NPV. So 9810 multiplied by 4.355 equal 42723.
722. Okay, 722.
723. Then the third year, year 6 present value 5,000 multiplied by 0.564 equal
2820.
Oh, God.
2820.
Yeah.
Then to get the NPV, you add up the positive present value, you net off the negative. Final answer. Okay, 5543. 5543. So that's the expected NPV. The second requirement, according to the question, you have to calculate standard deviation of NPV. Again, before you put down your formula, you must ensure you understand the nature of the cash inflow. So I will say standard deviation of NPV. Standard deviation of net present value. All right. So standard deviation of NPV is calculated as, I would then, before I put down the formula, we go back to the question, what's the nature of my cash flow? The cash inflow given to you, they are mutually dependent because the cash flow of year 1 is the same thing as cash flow of year 2, is the same thing of cash flow of year 3, 4, 5, and 6. So they are mutually dependent. So if they are mutually dependent, then standard deviation of NPV will be computed as standard deviation multiplied by annuity factor. So in this case, we need to go and calculate standard deviation. We need to go and calculate standard deviation. So I will then come here. We have calculated variance before. All right, we have calculated variance to be 6741. So let me just manage here. Therefore, standard deviation will then be equal to square root of variance. which is summation of probability of x minus x bar square. So in this case, that will be square root of 6741,900. So what do you have there? So I will then bring out the calculator. 6741,900 square roots. That's 2597.
97.
Here is 2597. That's the standard deviation. Let me make this one different. Okay. So that's the standard deviation. Now that we have calculated the standard deviation, I would then say 2597 multiplied by annuity factor of 4.355. Okay. So 2597 multiplied by 4.355 equal 11,310. That's 11,310. 11,310. So that's the standard deviation of the NPV. So this is how to calculate standard deviation of NPV, where you are given mutually dependent cash flow. All right. And I told you that mutually dependent cash flow is the one in which the events in each year are the same. All right. So the same event will affect all the cash flows. That means they are mutually dependent. Finally, number 3 of this question, you are to calculate coefficients of variation. All right. So coefficients of variation, CV. So the formula you will use to calculate your coefficient of variation will depend on the standard deviation and the expected value you have calculated. In this question, we have calculated standard deviation of NPV. You have also calculated expected next present value. Therefore, our standard deviation is 11,310. Sorry, yes, standard deviation of NPV is 11,310. Then expected NPV is 5543. So this will give us 2 point what?
200 divided
2.040. 2.040.
2.04.
2.04.
2.04 is the coefficient of variation. That's it. That's it. That's end of the question. That's end of the question. All right. Let me know if you have any question. Yes, David, talk to me.
Okay, good evening, sir. And please,
Yeah.
my network was unstable, so I don't know if you explained why contribution times sales volume is equal to cash flow. I know when we're doing capital budgeting, to convert profit to cash flow, we also did profit plus depreciation. How is that cash flow? Like I want to get the reason.
Why cash flow is a contribution? What's the
Yeah, contribution times volume now, sales volume.
when you multiply contribution with units, won't you have a total contribution? Total contribution is the same thing as cash flow now. If you multiply selling price with units, you are going to have total sales. Your sales is cash flow. If you multiply variable costs by your units, you get total variable cost. Your total variable cost is cash flow. All right. So multiply units with contribution per unit is cash flow too. All right, David.
Okay, I don't know, but what about the profit plus depreciation?
Do you have any profit in this question, or are you giving any
No,
depreciation in the?
no,
Why do you?
I'm just saying I know it's taking us back, but if you can just give a short reason why profit plus depreciation is cash flow. Or I
Okay.
might maybe ask you later in your DM.
You can DM me. That's is if you go back to your video, you will see all those explanations there. It's like you are drawing us back. Yeah.
It's not
But
good.
in any case, let me just tell you. So there's no need for to DM on this. I've already explained to you when we had capital budgeting, we said that okay, cash flow is equal to profit or loss plus depreciation. Okay. If you are given cash flow and then you want to calculate, you want to determine profit, therefore, profits or loss equal to cash flow minus depreciation. Okay. So you are now asking, why is profit for plus depreciation equal to cash flow? It's simple. I explained to you that when you are calculating, when you are evaluating a project using NPV, IRR, payback period, you need cash flow, right? You need cash flow. So if accounting profit is given to you, because you don't use accounting profit to calculate NPV, you don't use accounting profit to calculate internal rate of return or payback period. It has to be cash flow. So to now get the cash flow, you need to calculate depreciation first because depreciation is a non-cash item. So you calculate depreciation, you add it to the profit, then it will give you your cash flow. So your question now is that why are you adding it? It's like you have a concept that okay, 1 plus 1 is equal to 2. You are now asking again, why is 1 plus 1 equal to 2? It's just a formula, right, David? It's just a formula. So whenever you want to calculate cash flow, if
And
under
no,
NPV, whenever you want to calculate cash flow, just add profit plus depreciation. It will give you what you are looking for. I don't know if that is sufficient to address your concern. David, talk to me.
okay, since it's just a formula, no problem, sir. Right, thank you.
Okay. Laura, what's your question?
Sorry, good evening, sir.
Good evening. How are you?
Fine, thank you. So please, I want to ask.
I'm missing your face. This online, eh? Talk to me. What's up?
So I want to ask
Yeah.
if you're given, if you're asked to calculate MPV or any of the other valuation methods in the exam, but you aren't asked
Yeah.
to advise, do you still go ahead to advise?
If you are given NPV,
Yes, if you're told to calculate MPV, IRR, or any of those
yes.
methods, but you aren't asked to advise the management, do
If
you
you are
still
not
go
asked,
ahead to advise?
if you are not asked to advise, no need to advise now. So you only
Okay.
advise if examiner has asked you. But in any case, there is nothing stopping you because you never can tell. You never can tell. Examiner may be expecting you to advise, and if you just ignore it, so that means you are going to lose valuable marks. So there is nothing stopping you. If you are given, you are asked to calculate NPV, payback period, IRR, but the examiner did not ask you to advise. So in this case, just go ahead and advise, even though you are not asked to advise, examiner cannot penalize you. All right. Yes, just go ahead and advise on the basis of NPV. That's all. All right. So you have done
All
all
right.
your calculations. Just go ahead, advise, and then move on. So you can't be penalized for doing that. All right. Good.
All right. Thank you, sir.
You are welcome. So let's move to, let's see. Let's find the remaining minutes to discuss sensitivity analysis. Let's talk about sensitivity analysis. Okay. Sensitivity analysis. Okay, let me just use, instead of switching to the study material, let me just use this one to explain it. What do you mean by sensitivity analysis? You know, anytime sensitivity analysis is just a technique of incorporating risk, okay, of incorporating risk in cash flow, in cash flow variability. So whenever you want to measure the risk associated with a project, or you want to incorporate risk into the cash flow, then you can also use sensitivity analysis. The sensitivity analysis measure the tolerable extent. Let me put it down because of time. This measures the tolerable extent to which a project NPV, to which a project's net present value can accommodate any change in variables. Okay. For this purpose, variables include, initial outlay, sales value, sales volume, okay, variable costs, contribution, fixed costs, savings or scrap value, cost of capital, and then project life. So these are what we call variable. What we are saying is that as far as sensitivity analysis is concerned, you want to know what is the extent to which any of these variables can change before the project will become unviable. All right. What if the initial outlay increased by 5%? Can the project NPV still be positive? If you reduce our sales value by 2%, can the project still be viable? So you want to know the extent to which a project NPV can accommodate any change in variable before the project will become unviable. That is what sensitivity analysis measure. Okay? So how do you then compute sensitivity margin? So calculating sensitivity margin of variable. Now, there are three different formulas that you can use to calculate sensitivity margin, depending on the variables that you want to calculate. For example, for all the variables excluding cost of capital and project life, then sensitivity margin, SM, of variable, sensitivity margin of variable will be computed as net present value divided by the present value of the variable. All right, multiplied by 100/1. Let's say, for example, you want to calculate sensitivity margin of sales value of sales. All right, so it will be NPV divided by present value of sales. If you want to calculate sensitivity margin of variable costs, it will be NPV divided by present value of variable cost. Okay, so whatever the variable, so just divide NPV. You want to know what's the extent to which the NPV can change. The variable can change before the NPV will become unviable. So this is one formula. Then to calculate sensitivity margin of cost of capital, okay, sensitivity margin of cost of capital, it will be equal to internal rate of return minus cost of capital divided by cost of capital multiplied by 100 over 1. The third formula that you can use to calculate sensitivity margin, okay? So sensitivity margin of project life. To get the sensitivity margin of project life, so pick the project life minus break-even point of project life divided by project life multiplied by 100 over 1. Okay, so PL, where PL equal to project life. Okay, BEP equal to break-even point. Okay, break-even point. That's it. That's it. So now, especially the third formula, you can't just go ahead and, of course, you need to first of all go and calculate the break-even point of project life. Before you can then calculate sensitivity margin of project life. So how do you then calculate break-even point of project life? So break-even point of project life can be calculated by carrying out the following procedure. Step 1, okay? Step 1, let me put it down as step. Step 1, you reduce the life of the project by 1. Reduce the life of the project by 1. Say, for example, this project has 5 years life. 1 minus 5, that will be 4. So you are going to use 4 years to calculate the NPV, useful life of 4 years, instead of useful life of 5 years. If the project life is 10 years, so 1 minus 10 years, that will remain 9 years. So you are going to calculate the cash flow. You discount the cash flow on the basis of 9 years, okay? So that's what I mean by reduce the life of the project by 1, okay? Then step 2, you calculate NPV of the reduced life. Calculate net present value of reduced life. Let me rewrite that. Of reduced life, okay, which is RL. Then step 3, you calculate, determine break-even point of project life using the formula below. Okay, using the formula below. Okay, so to now get the break-even point of project life, you are just calculating internal rate of return. So this should be reduced life plus net present value of the reduced life over net present value of reduced life plus net present value of normal life. All of this multiplied by normal life minus reduced life. So that will give you the break-even point of project life. All right, so that's that. Once you have the break-even point of project life, then of course your answer must be expressed in years. Okay, Your answer must be expressed in years, not in percentage. So once you have the break-even point of project life, then you can proceed to calculate the sensitivity margin of project life. Okay, so that is as per that. The last area we are going to talk about, first thing first, note.
To
When
this
calculating the sensitivity margin of sales volume, when calculating the sensitivity margin of sales volume, the present value of contribution should be used as the denominator. Okay, so that's that. Then finally, anytime you have computed sensitivity margin, you need to interpret your results. All right. Now, one thing you need to know is that this sensitivity margin is very practical, even in real life. That's why, if you are conversant if you use Excel to work in the office, you will notice that at the top menu of your Excel, when you click on those menu, you will see sensitivity margin there. You will see what if. You will see what if. Of course, you can call it sensitivity analysis, or you call it what if analysis or switch test analysis. It's still the same thing. So on your Excel, you will see it on the top menu. You see there what if analysis. All right. So it's the same thing as a sensitivity analysis. So anytime you have computed sensitivity margin, you are supposed to interpret your results. So interpretation, you are supposed to interpret your result. There are two different ways you can interpret your result depending on the variable. Now, for all variables, okay, for the variables, let me put it that way. For variables such as sales value, sales volume, scrap value, contribution, project life savings. Okay, then the interpretation should be the percentage attained. Let me put it this way. Interpretation. Okay, the interpretation should be the percentage attained, or the variable should not be allowed to fall below the percentage attained. Otherwise, the projects will not be viable, or will become unviable. So anytime you have computed sensitivity margin for sales value, sales volume, contribution, savings, project life, so your interpretation should be that the percentage that you have achieved should not be allowed to fall below. If not, then the project will not be viable. Say, for example, you have calculated contribution. You have calculated sensitivity margin of contribution and you got 5%. The interpretation of that is that your contribution can still fall by 5%. Anything below Anything above that 5%, then the project will not be viable again. Okay, so anything below that, it won't be viable again. So that's the interpretation of that. If you're, for example, okay, let me go through the other one, which is number 2 for
No, this is 7 o'clock for my
variables.
daughter.
For variables such as initial outlay, variable cost, fixed cost, cost of capital, then interpretation. So the percentage or the variable, I would then say the variable should not increase, below, sorry, should not increase above, should not increase beyond the percentage attained. If not, the projects will not be viable. So that's the interpretation. Whenever you have initial outlay, variable cost, fixed cost, or cost of capital, all right? So for example, if you have calculated sensitivity margin of variable cost and you have 4%, it means that the variable cost can still increase by 4%, okay? Anything above that 4%, then the project will become unviable. Okay, the project will become unviable. So anytime you are referring to any of these variables, so the percentage that you have calculated should not increase beyond what it is. Otherwise, the project will not be viable. Now, for these other variables, okay, like sales value, sales volume, contribution, project life, saving, whatever the percentage that you have calculated should not be allowed to fall below, all right? Because if your selling price is reduced below the percentage attained, then the decision to undertake the project may change, all right? That means the project will not be viable. So in that case, it will not be undertaken. So that's that. So anytime you have computed sensitivity margin, it's expected that you are going to interpret your result. Don't wait for examiner to ask you, because oftentimes examiner may not ask you to interpret your result, but it is implied in the question, because how will you advise? How will you know whether the project is viable or not if you don't advise? All right. So anytime you have calculated sensitivity margin, you just have to interpret your result. Okay. Yeah, so in our next class, by the grace of God, we are going to have calculation under sensitivity analysis. Once we are done with our calculation, we then move to simulation. After simulation, we do decision tree. All right, we do decision tree. Yes, Ogechi, talk to me. Okay.
Okay, sir, I just wanted to ask if we can
Yeah.
have other past question materials to make reference to. I know this is the first time you're having SM, but if there is anything that relates to past questions just for extra practice, that would be nice.
For
You can
extract,
help
of
us.
course. Yeah, you can always search for it. But again, when you go to, you can always find a question on this under sensitivity analysis or any of the technique. You can always get question on that. So you can use SFM question or to, it's still the same thing. SFM is not different from financial management, except that, the kind of question you meet on the day of your exam under SFM is different from financial management. All right? So you can always get additional illustration to practice. Yeah. Somebody, Glory, you are pointing. Yeah, what are you pointing? I can't see that. You are not asking any question. Huh? You are directing you are pointing up to what? There is no question
Previous,
here. Yeah, Glory, talk to me. What's
previous,
up?
I wanted to ask a question initially, but I went through the explanation and I think I understand it.
Oh,
That's
okay.
why. It was regarding the mutually dependent and independent events. So I
Oh, okay.
wanted to ask initially, um, but I discovered that for the mutually dependent, it's our cash flow has to be constant for us to use the annuity factor. Why for the other one, because they are independent, then we use the other
Formula.
factor, the other form. Yes, so I was
Yeah,
able to get it.
it's okay. No worries. No worries. Okay. Yes. Any other question so that we can close the class? Some of you have disappeared. I understand. Yes. Okay. So in the absence of no further question, let me see. Andrew is still available. Angela, David, Edith, Anita, Esther is still on. Ruth is on. Foluke, Glory, Grace, Abdulhamid, then Joseph. Joseph, are you in this class? I did not hear your voice today. Where is Femi? Femi too is not in this class
I'm
today.
active, sir.
Joseph.
I'm in this class, I'm active. Sir,
Okay. Even Kemi, did you talk today at all?
I'm not in proxy.
Okay. Kemi, are you in this class? I'm not sure if you have spoken today. Oreoluwa, I couldn't hear your voice. Priska, Samiat, you
Good
too.
evening,
You did
sir.
not. How are you? So Samiat did not say anything today in the class. Same thing with Seda. Anyway, I believe next time maybe I will need to be calling your name one by one. So this one you are just some of you are just hiding somewhere and then allow me to be doing. How can I be reading question while you are there? Just relax, eh? So going forward, I'll be calling your name so that you can participate. Okay,
We are for
then. Okay. No worries. All right. Thank you guys for your time and patience. I will see you again next time by the grace of God. Good night, everyone.
Good
good night,
night,
sir.
sir.
Good night, sir.
It's a
Good
Thank
pleasure.
you.
night.
Good
You're
night, sir.
welcome.
Nice, thank you very much.
Good night.
Happy
Night,
weekend.
sir.
All
Good
right.
night, sir.
Which weekend?
Good.
Weekend has already ended now.
No, we still have tomorrow. We still have tomorrow. Okay. Um.